Number 2 is coming from quadratics. A line has this equation and the curve has also this equation where c is a constant. Showing all necessary working, determine whether the following statements, determine which of the following statements is correct. The line and the curve intersect only for a particular set of values of x. The line and the curve intersect for all values of c. And the line and the curve do not intersect for any values of x. Now, we need to find the intersection of these two. That is, if it is there. For intersection, then all of them are equal to y, so I'll just equate them. I'll have cx squared, then plus 3x, then minus c will be equal to 2cx, then plus 3. So bringing everything this side to form a quadratic equation, we shall have cx squared. The ones that have gotten x are this one and this. So we shall have 3, then minus 2c of x, then minus c minus 3 is our constant term. Now this is the quadratic equation we have gotten for the solution of these two. That means we are supposed to solve this, okay? Now using the quadratic formula, x, we can get it from minus b plus or minus to the root of b squared minus 4ac, right? Out of 2a. Now, this discriminant here in the square root is the one that is responsible to tell us the nature of the roots. Are they real and distinct? That is when this one is greater than what? 0. So that means you're going to have those two roots where you use the plus and then the minus. And then when this one is equal to 0, then that means this whole thing is going to go, and then we remain with minus b over 2a, which becomes the repeated root. And then if this one is less than 0, it is a negative. You're not going to be in position to get the real values when you take the square root. So you will be getting the complex roots. So for that case, you don't have a solution in the real system, okay? But now, here, our b squared minus 4ac is the one that we should focus on. What is the value of this b squared minus 4ac? You are not supposed to say b squared minus 4ac is maybe equal to 0. They have not told you that this one is a tangent. You are not supposed to say it is greater than 0. Just find its expression, and then from there we can judge. So b is 3, then minus 2c, okay, squared, then minus 4. Our a is the c, and then our c here, that is the constant term, is the whole of this negative c, then minus 3, okay. Now, when we expand this one here, square the 3, you get a 9. Then 2 times 3 times negative 2c, that one will give us negative 12c. Okay, then when we square this one here, it will give us 4c squared. And then negative 4c here times negative 4c, times negative c, that one will give us a positive 4c squared. Negative 4c times negative 3, that one will give us positive 12c. Now, this positive 12c cancels with the negative 12c. Then this one here is 8c squared, then plus this 9 here. Okay. Now, suppose we had gotten another quadratic expression, because this one is very easy, another quadratic expression that is not factorized, then you can complete squares, okay, to tell us that it is maybe something, then x, or maybe it is, this one is going to be in terms of c, then plus whatever is here, then squared, and then plus whatever is here, okay? And then you can judge from here, all values of c, this one will be positive, if, like that. So, but then this one is already exact, like this. So for all values of c, whether negative or positive, for all values of c, this hc squared will always be greater than what? Greater than or equal to 0. So I'm putting or equal because c can be 0, and I've said for all values. That means if this one is positive, when I put it here, the whole thing will become a positive, right? So this simply implies that b squared minus 4ac will always be greater than 0, okay? So what does this mean? So this leads us to b. Because they said for b, the line and the curve intersect for all values of what? C. So I will say this leads us to option B. Okay, so that is that. The line and the curve intersect for all values of what? Of C. As simple as that.